So first of all, I'm really excited to be speaking here. It is the first GraphQL conference, like the official one. And yeah, I would also appreciate if like anyone can take pictures and like post it on Twitter with the GraphQL conference or GraphQL conf hashtag on Twitter to get people to know more about it. And let's get started, shall we? Cool. So let's start by a little bit about me. So I'm Yassin Eldeeb. I'm from Egypt. I work at the Guild at all sorts of open source projects, particularly related to APIs and GraphQL. We've been expanding into many, like pretty much like a lot of areas. I love adrenaline-filled activities, and I am obsessed with performance. I also work on this project called Conductor, which is a powerful GraphQL gateway for federated subgraphs, but that is not our topic. That is Dotan's topic, the one sitting behind you. And so this talk is going to be about Rust-powered full-stack GraphQL. So the subtitle is From Actix-Web and Juniper Server to WASM Yew Client. So it's basically, we're going to build like a very simple full-stack GraphQL application in Rust so that you can get familiar with the Rust tooling around it. I think an interesting question is, can you raise your hand, like anyone have used Rust before? Oh, okay, that's allowed. That's more than I expected. So let's get started. So what is the purpose of this workshop? It is not to push Rust. It is using Rust when it makes sense. Yeah. And so the workshop goals is, first of all, to familiarize you with the Rust GraphQL libraries and tools. The second thing is to familiarize you and getting you excited, like with people who have never used Rust before. And I walked through over the usage of every tool that we're going to be discussing. And you're going to learn about when it makes sense to choose Rust, because it's not always the case. And so some prerequisites. Experience with GraphQL. I hope everyone experienced with GraphQL, okay? And some Rust knowledge, but even though it's not necessary, because we're going to be looking at relatively basic code, but a Rust knowledge would really help. A Rust C version of like 1.70.0 or bigger. And you have to have like the install trunk, which we're going to discuss later what it is. And you have to install the WebAssembly toolchain. Unfortunately, I wished we could do like a code along session, but I'm not really sure that would really work because the internet here is not going to be that good. But feel free to follow along, but yeah. So about the tech stack, as in the subtitle, we're going to be using WebAssembly. And WebAssembly is basically a build target that most browsers can understand. Like till today, there is Edge, Chrome, Firefox, and I think also Opera. Both, like all four of them, support WebAssembly as a build target. And WebAssembly is basically a binary, like a low-level code that has been built, and it's efficient, and it runs on the browser. That is like the second language that can run on the browser, aside from JavaScript. The second tool is Actix-Web, and Actix-Web is an HTTP server written in Rust. And it's currently one of like the top ranked HTTP servers in terms of performance. And we're going to be talking about Juniper. Juniper is a GraphQL library, like a library in Rust, so that it can enable you to write GraphQL servers. And we're going to discuss Yew, Yew.rs. Yew.rs is a front-end framework highly inspired by React.js. And it enables you to build front-end applications in a convenient way, similar to how React works, but in Rust. And so let's see some code. And so also I will show you the repo. So this is the repository for people who want to follow along. It's called, yeah, I think, can you see it? Yes. And so this repository basically have 7 branches, and each branch would be the section that we're going to go through. So each section represents a specific topic that we're going to be discussing. And can we start? Yes. And so I will check out to the first branch, and I think I've already done that. Oh yes, I'm already in the wrong directory. And so we have this GraphQL project. We have the cargo.toml, which is basically like package.json for people who are coming from a Node or JavaScript background. And it's pretty similar to how package.json works. It's like a package. You can specify the name, the version, the edition. There's multiple edition, and like that is the 2021 edition. And you can list your dependencies. There's also like the dev dependencies that you can list here. And we currently have none because it's just the initialization of the project. And this was done just by doing cargo new and then the name of the project, which was GraphQL in my case. And let's go to the source. So this is just the init of like a cargo crate, and the crate is the name for like that corresponds to like a package in the Node or the JavaScript world, which is just for project. We can use cargo run so that we can run this project, but we have to cd into the GraphQL directory into cargo run, just to make sure that our our installed Rust version is correct. We can have something working. The Rust C version works, and so we get the hello world. So we can compile something, and let's go to the next section. Branch, which is setting up Actix-Web HTTP server. I should clear this up. And so this is the next step. So what have changed from the last branch? We've added the Actix-Web dependency, which is the HTTP server, and we have added the env logger, which is a crate that helps us with logging like in the server. And as you can see here, what have changed is that we are initting this env logger, which is going to help us with like logging stuff as the server is running and receiving requests. And we have this server, and so we're instantiating like a new HTTP server from Actix-Web, and we're passing it the app, like we're instantiating a new app in the Actix-Web, and we're wrapping it with this logger middleware, so that as we're receiving requests, we can see logs as users are hitting our API. And we have this service, which is basically what you use when you want to have an endpoint, to initialize an endpoint, and attach a handler to it, as we're doing here. So we're saying that anything that comes to the /endpoint is going to be routed like to the get. So like we're handling only the get situation at the /, and we're mapping it to the handle incoming request, which is the function that's going to be executed so that it can retrieve the response. And we can run that, go run. And so the HTTP server is running, and then we can command click so that we can see that. And so we get the I can handle requests. So we can, like we currently have like a basic like HTTP server in Actix-Web. And the next step would be to add GraphQL to it. Let's move to the third branch, which is setting up Juniper GraphQL. And so a lot of stuff has happened. Let's also start with the cargo.toml. What have changed here? We have added Juniper as a dependency, and we've also added Juniper Actix, which is a wrapper that can help us with integrating Juniper and Actix. It basically helps us in intercepting the execution of the request in an Actix-Web to get the relevant information that we need to execute the GraphQL request. And let's go to the main.rs, where we always start. What have changed here is that, so this is just a basic struct representing a database of users. This also can be like a database connection. And this is, we have like a new function that inserts all of those users. And like we have a method on it so that we can get the user by ID. We can collapse that as it's not very relevant. And we have this struct user with the ID and name. And see this derived GraphQL object. So we're deriving the GraphQL object over the user so that we can make this struct a GraphQL type. So this is the equivalent of doing like a type user and then doing ID like int name string, but in Rust. And also one interesting thing is that this is like the code first approach, but I couldn't find any like SDL first because it's a bit, I don't think anyone like appreciate it because like Rust's whole mentality is about type safety, and having an SDL first approach makes us reinvent the code generation again, and having like duplicates of the types in Rust and the SDL. And so next is we are extending, or we are implementing this Juniper context trait. And in Rust, a trait is like a class. So implementing a trait is like extending a class. So this database now is accessible in any GraphQL like field resolver. And so next thing is that we have like a blank implementation of the struct query. And this is so that we can implement query on it. And then we are passing the GraphQL object derive so that we make the database accessible within the context. And we have this API version. And so anything here, any of these methods are basically representing all of the fields that are going to be on type. So this is equivalent to having type query and having API version. String, and having user, and it returning like the user type, which has been defined above. And we have this user field resolver, which has access to the context, which is our like in-memory database. And we're accepting this ID, which is an I32, which is an integer. And Rust or Juniper was able to infer this type. And it would automatically like add this as the following. So it's going to be like type query. It's going to be the user field, and it's going to be ID int, because it has inferred that this is like an ID of an integer. So they generated like GraphQL query or the type is going to accept an ID of an integer. And we're using the context so that we can use the getUser method to retrieve the ID of the user. And this is just like the schema type. Like we have the query, we're passing the query above, and we're passing empty mutation, empty subscriptions, because we don't have any. We have this function that is called the schema, and we're instantiating the schema with our query, which we have already implemented the fields on it. And we have an empty mutation, and we're also instantiating an empty subscription because we don't have any, and it requires passing those. We have a playground route, which is, we have this playground handler, which is exported from the Juniper Actix, which is like the thing that glues both Juniper and Actix-Web together. And we're passing it this GraphQL input URL, which is /GraphQL. So this is gonna show us like the very popular GraphQL playground. And we have the subscriptions endpoint URL set to none because we don't have any. And this is the function that we would use to handle the incoming GraphQL requests. We're using the context, which is our database, and we're using this GraphQL handler, which is also one of the like glue that is used to use both Juniper and Actix together. And so let's go down to the main function. We're instantiating the logger. We have the Actix-Web that we have discussed before. But now what's interesting is that we're adding this new app data, which is our schema. So we're injecting into the app data. So the app data is some piece of data that you want to share or want to access at any incoming request handler. And we have the service, which is the /GraphQL, and we have we're basically handling the get on that /GraphQL, which we're showing the playground route, and we're handling the post operation so that we can handle the GraphQL route, which is what gets us the actual response data, not shows us the UI. And so we need to pass this app data, which is like the schema, because like the wrapper or the glue, which is Juniper Actix, uses this data so that it can resolve like the incoming GraphQL requests. And we have the URL, which we're binding the server to port 4000 at localhost. And so let's run it. Cargo run. We should see two things now when we go to 4000. Of course, this is the root. We don't see anything. We can go to /GraphQL, and now we would see the GraphQL playground. We can access the API version and see like it maps to this, to the query, and we have this. But one thing you're gonna see, and it's kind of weird, is that this API version has like this slash between it, and it has been converted to like a camel case, because it's like the convention in the JavaScript world, or to have like a camel case. We can also query the user, the ID and the name on it, and when we hit save, or not save, we hit run, we need to pass the ID, which is an integer. In this case, it's 1. So passing this, so we get a proper GraphQL response. And as you can see here, so we don't get anything here, even though we've set up the logger. But if we need to see logs, we need to configure this so that we can pass the Rust log with the log level. It's pretty much as everything, as like in other like ecosystems. We have like the info, we have the debug, we have the trace, and each one has its own power and like shows different logs. So in this case, we want to see maybe the debug, which is a bit more verbose. Cargo run. And so if we hit this multiple times, you're gonna see all of the logs here representing like each request. So I've hit it with my Intel macOS, on my Firefox, and the date, and like it shows like what protocol was it on, and the status code. So that sums up our Actix-Web server. So we currently have gone through setting up a cargo project, how to get a like Actix-Web running, and how to get Juniper working with Actix-Web. And by the way, I want to show you something. Actix-Web performance rank. There's this very popular website, which is Tech and Power. It shows all of the ranks of like all of the HTTP servers across like all languages. Oh, it's worth the wait, okay. I'm waiting. Okay, this doesn't seem to have been showing it, but maybe here. Okay, we can skip this, but basically what I wanted to show you is that Actix-Web is ranked like, I think, one of the top 10 HTTP frameworks across all of the languages. I think it's only like behind like the Dragon framework, which is like a C++ HTTP server. And I think we can go to the next section. But if someone has any questions, is there any questions over what we have gone through? Okay. Okay. Sorry, what?
I have a couple. So one, for example, I've been asked to remove like the schema in production, and I see that in this scenario, like the playground is kind of like exposed. So how would you, for example, like do like environmental configurations to not expose the GraphQL in production environment?
Okay, so basically what we could do is that we have in Rust we have this use env, which is one of the, I think it was this env, as in here. Oh, I'm not sure. Yeah, it's here, and the from the standard library, and then using this you can read which env variables have been passed. So for example, you can use this. For example, like environment, development, and then using the env module in the standard library, you can check if this env is development, and if so, you can attach the playground, but if not, you can exclude it.
So that's not mandatory.
Yeah. Any other questions? Okay, I think we can go. We can go to the, of course, yeah, add course. I always leave it at the end because I always add it whenever I see the error. I don't know, it feels satisfying when you resolve it. This is, are we on the, yes, we're on the course section. And as you can see here, the only thing that changed is that we're also attaching another wrap next to the logger, which is the cores, which comes from the Actix cores dependency. I should have also shown the cargo toml. So this has been also added, the Actix cores, which is pretty similar to like Express cores. Like it's very light usage. Like you get the default cores configuration. I'm allowing every origin, and I'm allowing the post and get requests, and I'm allowing the headers of like authorization accept. I'm not really using those, but this is how to do it. I'm also allowing the content type, and I'm supporting credentials, which is like it makes you accept the cookie that comes with the request, and the max age is 360 or 3,600 milliseconds, and there's a lot of methods here. And so this would allow us to hit it from our front-end app without getting the casual cores issue. And so the next thing, which is one of the exciting ones, which is setting up WebAssembly front-end. So I think another interesting question is, how many of you are front-end developers in any language, any tech? Oh, wow, okay. That is very interesting. So we're setting up WASM frontend, and this is very good knowledge to have because Yew.rs is highly inspired by React.js. It has almost all of the methods, but it works a bit weird, like not exactly, even though they have the exact name concepts or terminologies. So we can go to the front-end crate. And it's also the same, like we've initialized it using the cargo new frontend, which have initiated this project. And so let's start with the cargo.toml. We have only one dependency, which is Yew, the framework that we're going to use to render stuff and on the browser. We're using version 0.20, which is currently the latest. And you're going to see we're enabling this feature, which is CSR. But what is it and why do we need it? So CSR stands for client-side rendering. And you would only need to enable it so that you can grab the renderer code. But if you're building a library, so for example, something like Bootstrap or something that explores a lot of components that you can reuse, so you don't need to export the CSR, which is like the renderer, because that is more bundle size than what you need. But in our case, we are rendering, and we are an actual app We're not a library developer, so we need that. You're going to also see this index.html, which is pretty similar to any front-end framework in the JavaScript world. It's like a blanket implementation. And then Yew.rs is a client-side rendering framework. It's not as Next.js. So what happens is that as soon as we hit the first request, we start populating this with like all of the elements. We can go to the source, add the main.rs, and this is very simple and very convenient. So we're importing all of the preload at star, which just basically gets us all of the helpful utilities that we're going to need. For example, should work here. I think I should restart my Rust analyzer, which is a very good extension, by the way. If you don't have it, let's call this. And then, okay, I'm waiting. Yes, so as you can see here, we can just say use, and you can see all like pretty close hooks. And like, of course, we have like, there's also the hooks concept, but you can see use callback, use context, use effect, use memo, use state, use reducer. All of those have been like highly inspired by React.js, but of course they have different implementation and they work a bit differently. So from what we can see here, we have this function that's called app, and this app is returning HTML, and we have this, what is HTML like, and this sign. So this is what is called in Rust, this is called macro, and macros are just like very powerful like utilities that can do many stuff. So it can accept literally anything here between like, it can accept like braces, it can accept like brackets with like infinite like variables. And what this HTML like parser does is that it takes what we have here and then it parses it, like parses the HTML so that it can allow us to have or to write HTML in Rust. And what it does is that it parses it so that it can render actual WebAssembly HTML so that we can just use the normal HTML we're used to. And it's actually not just HTML, it's like a bit similar to JSX because it also requires us to have one parent element, but I'm gonna show you first how to run it because, well, before I go in depth. The second thing is that we're instantiating this renderer, which I've just mentioned only comes if you specify the CSR feature, and we're instantiating it and we're rendering it. So how to start it? We can cd into the front end, and the normal thing that you would do cargo run, but that won't work because cargo is not really intended to run like WebAssembly. We're gonna wait for it so we can show it. Yes, and we get a crash because we can't call the WASM bindgen like a cargo run environment. So what we can use here is a tool called trunk, which is one of the prerequisites that we have had, which is cargo install trunk. And then after you have it, you can use trunk serve, which is basically a development server for WebAssembly. And it has hot module reload, so it can maintain the state, it can auto-refresh. It's a bit slower or much slower than like what we have in the JavaScript world because it is still like a compiled language. So it takes a second, like between as you save something and as it reflects on the browser. You can do serve, and I can also pass the open flag, which would open on my browser automatically. And then we wait. And we have it. So this is our very simple header GraphQL Conf 2023, and it's running on the 8080 board. So what I was mentioning earlier is that this is not just normal HTML. So if we added this, for example, which we would expect to work, like another element next to it, it's not going to show. And I think if we did this in the inspect, okay, so we don't see an error here, but we see an error there, which is a very popular and common error in React, which is that like any component have to have one root HTML element, but we currently have two sibling ones. So what can we do here? We can use dev, but it also has support for fragments, just like React.js. So we can do this to wrap those sibling or adjacent elements. And of course, yeah, I need to wrap this. And then we can see this. So it is a bit similar to React. It's not just HTML. It is HTML, but has some syntactical sugar like fragments. What else? Oh yeah, one interesting thing is that as you see here in the desk directory, which is pretty similar to how like JavaScript frameworks do it, you're gonna see the index.html, which is like it took the blank HTML we have had, but it's pointing or linking both a WASM binary and a JavaScript file. And you would say, but why does it have JavaScript? Because like we're supposed to be writing WebAssembly. Why did it emit like a JavaScript file? But if we took a look here, this is basically the bridge or the glue between the browser and WebAssembly. So this basically manages like the memory between like the browser and like the actual binary. It is basically the translator between like the web and the WebAssembly binary. As you can see here, we have like get int32 memory. We also have like above like a heap. We're instantiating a heap. So you can call it our little runtime. I think we are done here at the front end or the basic Vue.rs. So to move to the next section.
Is that runtime going to be different every time that we run the project, or is it always going to be the same?
You mean like in different environments, like development environment?
I mean,
Or?
if you're adding like different functionalities, going to grow in complexity and then it can become like a bigger JavaScript file, or is it just basic functionality?
The JavaScript file is just like a static file. It doesn't change. It's just a little runtime that is static that is shipped with every little WASM file.
So that can be pushed to like a CDN or something?
Yeah, exactly. It's you're gonna push it like as you push any front-end framework, you're gonna push like this test directory, and like it's gonna read the index.html, and we're loading those. We're linking those WebAssembly and JavaScript files, and like this JavaScript file just does the bridging between the web and the WebAssembly, and this is just gonna sit there and it's gonna be deployed as any JavaScript file, because like the major browsers like Chrome, Firefox, Edge, and Opera supports like WebAssembly. So it's going to be deployed as any JavaScript file, like the WebAssembly file. Any questions? Okay, we can move on. So, oh, I have another course, okay. I think I would go with the sixth section, which is GraphQL code generation. That's a pretty interesting one. So if you have gone to the front end, we are going to also start with the cargo.toml. So a lot of things have changed here. There is a lot that got added. We have the SERDI, which is, SERDI is like a crate that enables you to serialize and deserialize JSON in Rust. And we have the WASM bindgen features, which enables you to use async await in WASM or assembly. And we have this very interesting library that I've found recently, which is GraphQL client. If you're familiar with the very popular GraphQL code generator in the JavaScript world, it is exactly that, but in Rust. And we're enabling the request feature so that it can, we can use it with the request crate. Request crate is an HTTP client we can use to send requests. And we're using this WASM logger and log. And so this enables us to use the normal console.log in Rust. So we can emit logs at the web client. So basically WASM logger is what does the bridging, and then log gives us a few useful macros like info, error, and so on. We can go to, so how to use the GraphQL client and what it does. So we can go to the documentation where everything is, GraphQL client, GitHub Rust. So this is the project that I'm referencing. And so it enables us to use generate. We can go to the generate docs. I think the CLI or the cogen, I think. This is the one. No, this is the one. Okay, this is the one. You can install it via cargo install GraphQL client CLI, and they're just using for so that they're forcing installing it so that you can, I think, deprecate the older one or a bad installment if it was. And so this is the usage of the generate client code. We can use GraphQL client after, of course, you install it, and use the generate command, and you can pass any of the below flags, which is helper version. You can also add one of those options, which changes it configures the GraphQL generator the same way as GraphQL code generator does. You can add directives or attributes at the generated structs. You can deprecate, you can change the deprecation strategy. You can change the module visibility. So everything is by default public, so everything is accessible, but you can change it so that maybe you have everything private, and then you specifically change the specific structs that you want to expose it. So it says default value is pub, which is public. And you have the output directory, so where are those generated files are going to be outputted. And you have the schema path. So for GraphQL, the GraphQL client, which is a GraphQL code generator, to work, you need to pass it a schema, your GraphQL schema, and an output directory. Those are the two required ones. And of course, the query path. So let's go to here, get this example. And as we have here, we have the GraphQL folder, we have the query.graphql. As you can see here, we have a query that's called getUser. We're passing an ID, which is integer. And we're selecting the API version and all of the fields we have on the user. And we also have another query that gets us all of the users without specifying a specific ID. And we can go here. We can use the command we've just copied. We need this, so the query path is GraphQL query .graphql, and the schema path is going to be, so that's one interesting thing. So this is the schema.json. This is an introspection response from a GraphQL API. And to get this, there's so many ways, there's so many JavaScript tools that can do that. And you can also send one manually and have it. But also the GraphQL client CLI comes with a tool that you can introspect the schema, but it's not necessary. You can introspect it whatever you would like. You can use GraphQL client introspect schema and pass it where is the GraphQL API. And the interesting thing also, it accepts both a schema.json, which is an introspection response, and it also accepts a GraphQL SDL, like indeed.graphql format or extension. And so I want to GraphQL client generate this query, and the schema path is going to be schema.json. What else do I have? Yes, so I've got this. So I've got this query.rs, and this is, as you can see, it has generated like a struct for get user. It has generated the module for the get user. So it is exposing the operation name, the query, all of the types, the GraphQL types, like this, the scalar types. And it has also exposed the variables. So we can like provide the variables in a type-safe way. And we also have the response data, which is the API version and the user, which is in this case, it's not, it can be null. So we have this option in Rust. So like for the people who don't know, the option is like an enum, and it can be either some or none. It can represent the null value, but in a type-safe way, because like, have you heard about the null author, like popular quote, which is like, the null was like my billion-dollar mistake. So Rust doesn't follow that. Rust doesn't have the null value. And it just have this enum that can represent like a some value or none value. And it forces you to use like this match statement. I can also write it here. So some value, some nullable value. And then you can, in the match arms, you can have this sum, and you can have access to the value, or you can have none, and you can handle the none situation. And this approach is pretty good, because if you didn't provide a handling for both of them, it's not going to compile. Like, you have to handle every nullable or every nullable value, yeah. We have this. We also have this for implementing the GraphQL query for the get user. So those are a lot of utilities that we're going to use and a lot of types that we're going to use in our front end. And this also, by the way, this GraphQL client, this works in any environment, WebAssembly, backend, everything. It's not tied to any like standard library. And so we can use this. So I'm going to delete this because I have this pretty cool thing that I've added. So as you can see here, unfortunately, the CLI only allows us to generate like bare one query. So if we have, for example, like 15 GraphQL query files, we would have to generate this command for each one of them, which is not very convenient. So I have this bash script. What it does is that it downloads the latest GraphQL schema introspection. I can also show you how it works. So I can delete the schema.json. But before introspecting, I have to have the backend API working first. Backend GraphQL, cargo run. So this is serving our GraphQL API. And then we can download the latest GraphQL schema introspection. And as you can see, as soon as we have ran this command, we have got this schema.json, which is our introspection response. What also can work is that you can have like a schema here, as I've mentioned, in like an SDL format, like query, name. And then if I do that, schema.graphql, you can see, okay, it has populated this already existing file. Well, I think, oh yeah, I have modified the output, not the, oh yeah, so I was modifying the input, so here. So aside from the code generation, I wanted to show you that we can also use the generate command, not the introspection, on a schema that is SDL. So it's saying that error generating module code, no field named API version on query. And that is correct, because we're passing it this, and we're passing the query.graphql, which has a lot of fields that the schema doesn't have. So it can accept both a schema.graphql and a schema.json. So the interesting thing that I wanted to show you and got sidetracked is we have this generate.sh, and we're downloading the latest GraphQL scheme introspection. We're making the source generated directory, which is this, and we're basically finding every file in the GraphQL folder that complies with like the .graphql extension. And then if so, we're looping over it. We're getting the file name variable, and we are running the generate command on each one of those file name paths. So that it's like an automated thing, and I don't have to generate for each query. So if I run this, if I didn't have this generated folder, and I also didn't have this, what else? I think, yeah, the schema.json as well. And I just ran generate. So this is gonna generate we're gonna run the introspection and write it, and we're also gonna regenerate all of the types that we need. So I can remove this and go back to the code, to the usage. Nothing has changed here. It's all only with the generation code. So I think this is a bit of a dense part. Anyone have any questions before going to using the client? Okay. We can go to the last section, which is fetching the data from the GraphQL server. And so we can start, I think we can also start with the cargo.toml, but yeah, it didn't change. We can only go to the main. And so what has changed here is that I'm just defining some alias types here for like I'm using the generated query get user response data, and the get users was an S. And I have those two types, and I have those two utilities to fetch an individual user or all of the users from my backend API. And we have this app function, which has been simple for like the entirety of the session, but now we have this new, like we're using much more capabilities of the Use.rs framework. So we're using this use state, which is exactly the same as React. It just doesn't return like a tuple for like users and set users. So like you get users here, and when you dereference it, so this is like a pointer. When you use the asterisk to dereference the variable or like this handler, this is gonna point to the data. And you can have this set, which is a replacement for like the set users, like people are used to in React.js. And so we're logging the users on every render of this component. And so we have this use effect, which is very similar to how React works. We're using, we have this function that runs, and we have some dependencies. In this case, it's just an empty thing, an empty tuple. And in here, we have this feature, and we're using this fetch users. We're awaiting over it. And as I've shown you, this returns like a result, which is another type safe thing from Rust that is pretty similar to option that I've shown you. And so option was either some or none, but results are either okay or error. So it forces you to have that. So for example, if I didn't have this error handling, you're gonna see we get some errors, and I will never be able to compile it. But it forces me to handle the errors. We have this, so we get this response after awaiting from the fetch users. And so we're setting this data using like data set, which is the state, to all of the response users. And we're catching this error, if so, and we're logging it. We're using log.error, which is just console.error, the equivalent of it. And we are spawning this, like we're basically, so async and await in Rust generally, it works normally, but when you introduce WebAssembly, it becomes a bit more, it needs a bit more configuration. For example, we needed the WASM, like in the cargo.toml, we needed the WASM bindgen features, and we also need to wrap it like in like a spawned environment here, so that it can execute this feature. Future is just like a promise in Rust. That's also a note. What else do we have? So yeah, this is just the utilities that we have for fetching the users. As you can see here, we're using the generated types for the get users, and we're using the type for the variables. So as you can see here, for example, we get type safety here when we're specifying the variable. And we're using the post GraphQL, which is a feature of GraphQL client, so that we can push this or send this request and get like the equivalent of sending this get users query, but in a type safe environment. And then we should see how it works. Trunk open, and it's compiling. And so we have it here. So as you can see here, we have this list. I haven't shown you the HTML then, yet. And we have all of those data that came from the in-memory users database that we have in the GraphQL API. We have all of those names listed. And as you can see here, if we see here, also we have the console.log. So this has been logged from our Rust WebAssembly using like the info or log info macro. And as you can see, we can see the value of the users, and it's formatted in like the Rust, the prettified Rust log. We can also see the network, which as you can see here, it sends one request to our localhost 4000 port, and we're sending this request, which is our GraphQL query, and we get this response, which is the API version and the users, which we're later using to iterate over them and display a list. So back to the code. I haven't shown you the HTML here. So we have the header that we have had before, but we're also iterating over this users, which is of type, this is of course just a wrapper. After dereferencing it, we get the actual value. And like dereferencing happens automatically. So it automatically follows the pointer to the data without actually using the asterisk. So this is of type vector of the get users. And so we're iterating over them, mapping it like the same method as in JavaScript. And we're returning this HTML template, which is like a header showing the ID and the name. And then we're collecting them because in Rust, when you map over like a vector, it works lazily as how it works recently in Bun.js. So you'd have to collect it so that you can actually get the value of it. And I'm specifying that it's like a vector of HTML. And so we can see a list here. I think we can go back to the keynote. So after we have seen some cool code, when does it make sense to use Rust? So in the code that we have, in the Fullstack app, like the backend and the frontend apps that we have built so far, this is very, very simple. And it doesn't necessarily depend on anything computationally expensive. It makes sense to use Rust when, for example, there's a couple of good examples. For example, there is Figma. They have this web Figma version, which is it shows the sidebars and the header is React, but the actual grid and all of the design tools are C++ compiled to WebAssembly. So this is a valid use case. There is also another use case when, for example, you upload 5 gigabytes of video and you want to compress it. How it usually happens is that it is sent to the server compresses it, and then it returns it back, but it takes long, so maybe they even email you an hour later saying that, hey, we have got your compressed video. But with this, you can actually use ffmpeg, so this very popular CLI tool that does a lot of video processing, And you can compress the video on the client side without stressing the backend. There is also a couple of use cases when you have like games. So for example, there's, if anyone knows the game Doom, there's like a web version of it. I think this, yeah, it is. So some people, like as soon as WebAssembly was supported, some people have compiled the game Doom, which is like a very, very old game, but in everyone's memory, to WebAssembly. I don't think it's gonna load, but yeah. And it works on the web, so without even installing it, like you're playing a game with like a lot of graphics on the web, and like at 60 or like 120 FPS. So those are the use cases where you would want to use Rust on the front end. But on the back end, it's like a very, very suitable language. I wouldn't say there's like some scenarios where I wouldn't choose Rust on the back end. It's very, very like pretty high performance. It's type safe. Like it's convenient when writing it. And I like its style, but some people might not like it. Yeah, those are the use cases. Are there any questions or opinions? Yeah, go ahead.
So the first one is I see the WASM file right now as it is, it's like over a megabyte long. So that means that when the user goes to the browser, he needs to download this binary.
Yes.
And does it get compressed or smaller or something?
Yes. So as like JavaScript files and like every asset that is served with browsers, everything is gzipped. So it's much, much less in size-wise, but it will always be bigger than the JavaScript implementation.
And this is like a dev version or the production version is much smaller?
Oh yeah, this is the development version. The production version is much, much faster and like much smaller. There's also in cargo.toml, you can specify like a config so that you can rather optimize for size rather than performance. So it's defaulted to optimize for performance and take a little bit more space, but you can also make it that it takes less space, but it is a bit slower. Go ahead.
Yeah, did I add that package for like WASM-powered to like access console log? Are any other things that have like side effects? Do you need to add like interop for WASM as well?
Sorry, can you raise your volume?
Oh yeah, sorry. So you have that package for like WASM-powered to get console log. Do you need other packages for like interop with browser features like accessing?
It's a good question. So we can go to the u.rs docs, and I'll show you all of the various modules that is needed. So we can go to the docs, and we have this. Okay, it's loading slowly. And if you see here in the concepts, or I think advanced, I think here. Let me see. Yes, so you have both of those, like WASM bindgen and WebSys. So WebSys provides access to all of the web APIs, so you can access Canvas, the DOM, everything through the web system crate. And no, it's just a bridge. So it's just you're accessing the JavaScript implementation. So yeah. Go ahead.
What scenarios have you seen a GraphQL server running as WASM be really useful?
A GraphQL server running as WASM?
This kind of implementation, running the GraphQL server thing.
You mean like a GraphQL server or like the GraphQL front end?
Yeah, front end, yeah.
Oh yeah. So yeah, one of the examples that I've mentioned, which is like Figma, games, like web compressors. There's also one of the things that I would encourage you to do, like after this talk, if you're interested further, which is it was called Rust WASM book. So there's a pretty good book that just shows you all like very, very detailed information about like WebAssembly, and the create with you like along the way this game. It's called Game of Life, where it's like, I don't know, like spread things and they like clash together, and then they like it's very intense, like in like the drawing of it, and they have made it in like JavaScript and Rust, and like the WebAssembly version was much like less laggy. It was running constantly on 60 FPS, when like on the JavaScript version I think it was like 20, 25. So that's one good example of it. Go ahead.
Is there any option of using relay with WASM?
Relay. There is not an option, but like there's like this GraphQL client, which provides a very similar way. So one of the things that you can access, so you can go here, for example, in the
Related question, the relay client as well. So for example, if I need global ID, is there any option available for me?
the relay what?
I need a global ID from the API server for the relay client you talk about.
Global ID for what specifically? Can you specify that?
Just like relay on WASM, if you have any idea for that, that would be awesome.
There's not a current like support for relay. There's like they have this own ecosystem. So no, I don't think it's possible. One thing though is that, which is very cool, you can have like a component. You can write just one component in Rust, and you can use it in your JavaScript app. So you can still use your favorite tools. Just write this one specific performance-intensive component. Go ahead.
Can we use multi-threads just like web workers?
Yes, yeah. And I can.
Is it provided by this WebSys library?
No, WebSys is only a crate that exposes the JavaScript web APIs. So yeah, if you want web workers, you can do that. But what's more interesting is that this is a binary that runs on the system. So you can actually use like the actual resources of the hardware rather than being limited of the web workers runtime. I think someone had a question. Yeah.
I wondered if you also provide async GraphQL.
Yes. So that's one thing. So I had in the last slide that I have, which is I would encourage everyone to continue further and learn async GraphQL. This is basically the author was inspired by Juniper and then wrote async GraphQL. It is a much feature-rich version of Juniper, and that's like what I would highly recommend for every GraphQL server. Yes, yeah. It also supports federation, which is a huge thing. Anyone has got any questions? Yes. Yo, so that is very tricky. Debugging WASM is like a nightmare. You can basically spend weeks. Like the errors are very difficult. But using like frameworks like Yew.rs, like it prettifies the errors a lot. And like in your CLI, you would always get like very helpful information. So what I have here, for example, I can like do any errors. Like for example here, I can remove this. And as you can see here, I get like a readable error and like a very simple error. But if I was not using like a framework like Yew.rs, I was like getting a lot of unreadable code, the WASM errors. But as you can see here, Yew.rs pretty much covers a lot of errors, and it shows you in like a very simple manner. But if you're just doing WebAssembly, just raw WebAssembly, it's not great.
Because I was thinking that one of the benefits of having like a server in Rust is that you can leverage like a lot of server-side rendering, but in this case, it seems that we're using client-side rendering, so the WASM is executing on the browser, right?
Mhm.
And then it's like, at least with JavaScript or TypeScript, then you can debug your hooks, and then you can debug the state changes. But here's probably everything's gonna be just done by logs, right?
Yeah. I think like for server-side rendering, you could just use like the Actix-Web server and implement it, but you wouldn't get the pretty good like utilities like use state, use effect, and all of those utilities. You would just handle the requests and like pass raw HTML. So server-side rendering is possible, but there's not really a tool that makes it like fun. Yeah. Go ahead.
So if you were to like build a like component using Yew.rs and then publish it as like a package, would it have any like interop with like a
No, so like, so Yew.rs also have its own virtual DOM, so there's no conflicting. Everyone just works on its own. So Yew.rs has its own virtual DOM, and React has its own virtual DOM, and this is running its own bubble, but it can be integrated anywhere. So there's, for example, there's this very cool, I'll show you. I think I'll go to the slides again, not this. This one, not this. Yes, or not this, I think. Yeah, this one. Read. Yes, I think this one. So someone has already done that and has posted like an example by integrating a Yew.rs component within a React project, which is like you don't have to really switch everything or rewrite everything, because we've seen a lot of projects fail when rewriting everything to Rust, which is a very popular saying. So this guy has a pretty good example. He has integrated both Yew.rs and React, so they work they work in the exact same project, and it works. Yeah. Anyone has questions? John?
Does Yew support routing? How do you do client-side routing?
Yeah, it does. So we have this Yew.rs route. The internet is kind of slow. Yes, okay, we have this router. So we have Yew router, which is, yeah, directly also like pretty similar to the name of React router. And we have this enum that you can specify all of your like home, secure, not found, and you can annotate them with the directives or the attributes of like at the endpoint. You can also like annotate it with the not found, which is like a special attribute, so that like if there was like it can show on the 404, but it can also show when you access a non-existing endpoint. And to go through this, they also have the use history, which is pretty similar to the like React use history. You can access like you can push, you can go back, you can access the history of it, you can access the params, the URL params, and you can also have like this switch statement here, which is pretty similar to how it's done in JavaScript. Like you access like the home, and then you pass in the component, which route, you pass the component, and so on. Any other questions? Okay, I think I would go on to the last slide, which is where can you go from here? So a lot of people covered it, which is a pretty good thing because that seems you're interested. So one thing, and the most popular thing, or the biggest thing, which is to try out async GraphQL. So async GraphQL is another library that you can use for creating GraphQL servers. It is, I would say, popular and it's much more feature rich. And it has already been built on what is in Juniper, and it's highly inspired by it. So syntax-wise, you wouldn't feel any difference, but you would get much more features. One also interesting thing is that you can use Tailwind CSS with Yew.rs. So for people who are a fan of Tailwind CSS, someone has written already a blog on how to integrate Trunk, which is like the development server, with Tailwind CSS. And I would also highly encourage you to read the Rust and WebAssembly book. It's pretty good. And you can also experiment with rewriting some computationally intensive operations to Rust. So for example, if you have like an app with like 90 components, and there's like one component, for example, I was working a year ago on a trading platform, like all of those like crazy graphs. And so these has always been laggy on the web. And the only way I could do it is by rewriting it to like using a Rust renderer and not like the Canvas or the JavaScript APIs. And I just replaced that one single component, and I was able to 3x the performance of the rendering. So you can experiment with rewriting like a few components that you're not happy with, like in your JavaScript frontend project. Also, you can experiment with integrating Vue.rs components in your JavaScript frontend code base, because you don't really have to just love one side. You can use both of them, and you can use both of them in the same project. And I think that's it. We already had pretty good questions, so do you have any further questions? Can we wrap it up? Okay. Okay.
You dropped content edition. Are we gonna hear more about that later?
Yeah. So Dotan, also from the guild, have like an entire like session on it. So that's pretty good.
Today as well.
Yeah. Or is it today? I don't know. I think it's in the conference, but I'm not sure if it's today or tomorrow. Oh, tomorrow, okay.
What's the question about what?
Conductor. Conductor is like, I can go to this. Yes. So, so it's a powerful GraphQL gateway for federated subgraphs. Like in a federation project, and like that has like multiple subgraphs, you can have this gateway, which is, it works similarly to like a poll router and wonder graph. And this is the guild's version of it. We can, like, you have like multiple like endpoints representing the different subgraphs, and you have like just one endpoint that combines all of your subgraphs, and it's very performant. Also, it's running in Rust. So yeah, I would hope this is gonna be interesting. Question?
Have you tried any other frameworks like Seed and Rockets apart from Vue?
Yes. So I've tried the Rocket and Hyper for like Rust HTTP servers, but Actix-Web has always performed the best. What is also interesting is that, have you heard of like the Yew WebSocket.js server, the underlying server used by Bun.js? So that actually outperforms it. It is an HTTP server written in C++, and it outperforms even Actix-Web. It's just about like the more higher level the server is. So like Hyper is a bit higher level. There's also, what else? The other thing, Tower, I think. There's like all of the other HTTP servers are more high level. They are more easy to use. But with Actix-Web, as you can see, like it's a bit more verbose. Like you can figure everything, and yeah, it's like a bit better in performance than all of the equivalent or the other HTTP servers. Is there any questions? Okay, should we wrap this up?